Hello, we're on 4.02 Algebra 2 notes today. And these ones are going to be on exponential functions. You hear a lot about exponential these days in the news, usually referring to the coronavirus and its exponential growth. So first of all, exponential functions, their general form is going to just be y equals a times b to the x. But we can get a little bit more specific depending on whether it's growth or decay. So let's talk about growth. So your growth factor is going to be b, and that's when b is going to be greater than 1. So your equation for exponential growth, which you've probably seen in algebra before, would be y equals a, so just keep the a, but your growth factor would be 1 plus r raised to the x. Now, a couple things to remember here. A is your initial amount. R is your growth rate. Remember the difference here, sometimes they ask for growth rate versus growth factor. Your growth factor, think of parentheses. When it's in, whenever it's in parentheses, just like we talked about our factor versus our zero value, our growth factor is this whole thing right here. So this whole thing right here is the growth factor, which is your b. So the growth factor is just 1 plus r. If you know the rate of increase, then b is equal to 1 plus r. So you're just substituting in 1 plus r in for b right there. And that's your growth factor. And this would be your rate of increase. Okay, then let's talk about if you are decaying, so getting smaller. So the decay factor would be b if b is between 0 and 1. So the equation for that would be y equals a times 1 minus r raised to the x. So again, a is going to be your initial amount, 1 minus r is going to be your decay factor. Think factors in parentheses. And again, your decay factor, we'll write that out here, is b equals 1 minus r. And this would be your rate of decrease. Remember, you can't put percents into your equation. You always have to change your percent to a decimal first. Okay, so important equations to remember. Other thing to remember is an asymptote that I know we've talked a little bit about this year and you may have heard of before. And let's just review what that is. So the asymptote is the line the graph gets closer and closer to, but never ever touches. It will never cross that line. And that is an asymptote. Okay, so let's go ahead and do a graph of an exponential. And we're going to put this right into our calculator to help us generate the table. So we're going to graph this. I'm going to set up my axes. Okay, and a table. And let's also talk about here before we graph it. So our parent function, we see that the variables in the exponent. So we know this is going to be an exponential graph. So again, you should know the shape of that graph. We know from this -3 out here that it's going to be shifted down 3. And we know here we have 0.85 raised to the 2x, and we're going to be talking about that a little bit more because when we talk about those exponentials, like in that form, you want it to be just x. So you actually could raise 0.85 to the second power to write it a little bit differently. But since we're just asked to graph it here, let's just put it right into our calculator. So I already have this in mind, so pause your video and please type that into your y equals just like I have right here. After that, I'm going to hit zoom 6 just to see what this graph looks like. Okay, and then making sure it's an exponential. I notice that it's going down. So this looks like it's going to be decay. And I'm going to go to my table. I want to make sure I choose some negative values and positive values and write them down in my table. So I've got -1, 3.9204, 0.2. And we're just going to have to estimate where these are on the graph since we do have a lot of decimals right here. But that's okay. We just estimate about where they would fall, and we'll still get a nice graph. Whoops. So 7 is -2.486. 8 is, actually I don't have 8. I'm just going to skip to 9 right here. I just didn't have 8 written down. But you could grab it as well. Now my table looks like I'm going up by 0.5, so if your table is a little funky like that too, maybe I start my table at -1 or 0, it doesn't matter, we can always scroll, and my change in table should be 1. There we go. So if you wanted to include 8, which I skipped over, is -2.629. Okay, so now we want to go ahead and graph these. So I need to get up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have enough room on my x-axis, and my y-axis, my highest value is almost 4, and I'm going to -2.3. So I can count by ones on all of those. All right, so I'm just going to go ahead and plot these points. -1, 1, 2, 3, and it's 3.9, so it's going to be really close to 4. 0, 2. I'm going to go 1 and then just up a little bit more than half. 3 is a little bit more than -1. 4, 5 is negative, a little more than -2. 6, 7, 8. You see we're getting pretty close together here. 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I must have skipped something in here. And that one looks a little off. So at 2, oh, I skipped 2. That was why. We'll just skip that one. And then 3. Sorry about that. I'm just going to redo mine. 1, 2, 3 is, I see there's 2. So 3 is -1, 4, 5 is -2, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, you don't have to have all of those points that I have. And we'll see here that it starts to look like it's leveling off, right? So you can notice from this graph and from your calculator here that we have an asymptote, and the asymptote is going to be at -3. Another way you could tell that is by looking at your equation. So normally if you have like y to the 0.85x, then you would have an asymptote at the x-axis. But since we shifted it down 3, the asymptote moves down 3 as well. So the asymptote is going to be y equals -3 for that equation. So something else that we're going to be looking at is we want to try to always get that x by itself. So if I go to my calculator here and type in 0.85 raised to the second power, I get 0.7225. So what I did was I just typed in this piece right here. So this equation would be the same as y equals 5 times 0.7225 raised to just the x minus 3. Once you have that x by itself in the exponent, so before it had a 2, now I just typed this into my calculator, and now it's just raised to the x power. Here's where now you can look at this and say, is this bigger than 1 or less than 1? And since that is less than 1, therefore you would know that this is exponential decay. But you can only do that once you have x alone in the exponent. We also know from our graph it's decay because we can see that it is clearly decreasing. All right. Let's do another question. So this next one is a Regents question. About rabbits. All right. Number 2. So a rabbit population, a little bit of writing first, doubles every 4 weeks. So since we're doubling, we're getting bigger, which means we are looking at exponential growth. There are currently 5 rabbits in a restricted area. If T represents the time in weeks, and P of T represents the population of rabbits with respect to time. About how many rabbits, and this is actually a multiple choice question on the Regents, will there be in 98 days? So that's why they're not that specific about how many rabbits, plus you're talking rabbits, so we're gonna round for that. All right, so we know we're having exponential growth. So I'm gonna start with y equals a times 1 plus r raised to the t. All right, so that's my exponential growth equation. So the question then is, what is my rate that I am increasing by? Well, I'm doubling every 4 weeks. So if I'm going to double every 4 weeks, then if I'm just doubling, don't focus on the 4 weeks yet. If I'm just doubling, that means I'm increasing by 100%, right? I'm doubling. So my rate is 100%. That means I'm doubling. I'm going to take exactly how many I have, and I have 100% of that added onto it the next week. So I can't use percents, so I need to change it to a decimal. So to the left gives me 1 as a decimal. My initial amount of rabbits is going to be 5. So first, let's look at how we could figure this out if we doubled every week. It says every 4 weeks, so I just want to see what I could do if I doubled every 1 week. So for that, I would take my initial amount, which is 5, and I would double it. My rate is 1. So you may have even be able to figure this equation out without doing any of the formulas. So y equals 5 times 2 to the t. So that's if we doubled every week. So let's see if it just works. Let's put in our t and then our y, or this is supposed to be p of t. All right, so let's say after the first week, if that's 1 week, then that would be 5 times 2, which is 10. If I put in 2 weeks, then that's 2 to the second, which is 4. So it'd be 5 times 2 to the second, which would give me 20. So the second week I took 10 and doubled that, so times 2 gave me 20. So that seems to work for every week. The problem is we want every 4 weeks. Okay, so are we doubling more or less if we double every 4 weeks? Are we going to have more rabbits at the end or less? And hopefully you're saying you're going to have less, because here we're doubling every week. So next week we would have double. Here, if we're doubling every 4 weeks, we're not going to have double until we reach 4 weeks. So that tells us that we need to change this exponent right here. So instead of every week, and we know t represents weeks, so instead of every week, we're doing every 4 weeks. So the question is, should we do 4 times t or t divided by 4? And since it's less, you want to do t divided by 4. Now let's see if that works out. So t and your y, which is, again, supposed to be p of t. All right, so if I take 1 week and then I substitute that in, that would be 2 raised to the 1/4 power. And that would give me, and you can type this in as well. Actually, you know what? Let's forget the 1 week. Let's do 4 weeks, because we want to see that it's going to double after 4 weeks. So this is the number of weeks. So now if I put in 4 over 4, that would be 1. So 5 times 2 would give me 10. So after 4 weeks, I'd have 10 rabbits. So then let's try after 8 weeks. So 8 weeks, we want this to double again. So 5 times 2 raised to the 8 over 4. So that would be 8 over 4 is 2. 5 times 2 to the second would be 20. So that seems to work as well. Okay, so now it wants to know how many rabbits will there be in 98 days. So we know that this tells us in how many weeks. So to figure out how many days, we need to convert 98 days into how many weeks. So if I'm going from days to weeks, is the number of weeks going to be bigger or smaller? Well, hopefully you're saying smaller, because we have 7 days in a week. So 7 days is bigger than 1 week. So I'm going to take my 98 days and divide that by 7. And if I take 98 divided by 7, that's going to give me 14 weeks. So now I need to figure out how many rabbits I'll have then. So P of t equals 5 times 2 raised to the 14 over 4. And then you just go to your calculator and we're going to type in. And you could actually put that in your y equals and graph it that way as well. So 5 times 2 raised to the 14 divided by 4. And we get 56.568. So approximately how many rabbits would that be? Approximately 56 rabbits. And the choices were 56, 152, 3,688, or 81,920. So 56 would be our final answer. Okay, and I'm going to go to the next page for this one. Which function, this is multiple choice again, represents exponential decay? And this one I'm going to give you your choices. So y equals 2 to the 0.3t. Choice B is y equals 1.2 to the 3t. C is y equals 1/2 raised to the negative t. And D is y equals 5 to the negative t. So the thing that you really need to remember here is you must get the exponent alone. So get the variable and the exponent alone. Okay, so before we can decide if it's decay or growth, I need to do that. So for this one, for letter A, I'm going to type in 2 raised to the 0.3. So this is a really important concept that comes up a lot in this course. So really important that you're typing this in. So 2 raised to the 0.3, oops, 2 raised to the 0.3 gives me 1.2311. So 1.2311. Now that would be raised to just the t power. Okay, for B, so that was A. We're going to type in 1.2 raised to the 3. So go to your calculator, type that in, 1.2 raised to the 3. And you get 1.728. So 1.728 raised to the t. For C, this time it's negative t, so negative 1t. We want it to be a positive t in the exponent, so we're going to type in 1/2 to the negative first. So I do 1/2 and raise that to the negative first. Or you could have, I just didn't put the parentheses around, so I did it in 2 separate steps. And that gives me 2. So that's really saying y equals 2 to the t. And then go ahead and do your last one. Pause the video, type that in, and you should have gotten 0.2t. Once I now have just t in all of the exponents and all of these, now I can compare them and say, okay, is this number bigger than 1? Yes, so that's going to be growth. Is this number bigger than 1? Yes, so that's also growth. Is this number bigger than 1? Yes, so that's also growth. Is this number bigger than 1? No. So that is going to be your decay. But before you can decide, so you can't just look at the original, because then decay, you probably would have chosen choice C if you did that, because that's the only one where the base is less than 1. You need to type in all of them before you make that decision. Okay, next we're going to look at translations. With exponential functions. So your parent function and then your shifts. So we're going to look at our general form first. So y equals a times b raised to the x minus h plus k. So when we look at this, your h is going to tell us left or right, opposite of what you think. So left is going to be positive, right is going to be negative. Your k is going to tell you your up-down shift, just like all the other parent functions. Up is positive, down is negative. All right, so now let's describe the shifts that happen and also state the equation for the asymptote. So describe the shifts or the transformations and state the asymptote. So remember, these exponential graphs are going to have an asymptote. So the first one is y equals 3 to the x minus 4 plus 1. So just by looking at that, we should be able to tell, number one, that our parent function, take off all your shifts, you're left with just y equals 3 to the x. So now what happens? Well, we did this -4 in the exponent. So in the exponent is left right. It's opposite of what you'd think. So that tells us it would go right 4, and then outside here, it tells us it's going to go up 1. And our asymptote equation, since there's this, the original, there's nothing being added, that would have an asymptote at y equals 0. Now we moved it up 1, so our asymptote will be y equals 1. Okay, let's try another one. Y equals -5 to the x. So first write down what is your parent function. And hopefully you're saying y equals 5 to the x. So you take off any negatives, any shifts, anything like that. All right, and where is this? Since the negative's in the front, we know it's just being reflected. So think about this. The negative is not on the x, which means it's really on the y. So if you had something like this, then you would divide both sides by -1, and you get y equals -5 to the x. So if the y is negated, then that tells us that we're reflecting over the x-axis because we negated y. And our asymptote, we don't have any vertical shift here, so that will just be y equals 0. Okay, try 4 to the x plus 2 minus 7. Pause the video, write down your parent function and any shifts that occur and your equation for the asymptote. Okay, so the parent function here would be take off all our shifts. We're just left with y equals 4 to the x. So just your variables and the base there. Your asymptote of that one would be y equals 0 because we don't have any vertical shifts for the parent functions. Now we're going to shift this left 2, down 7. There's no negatives in the front. X is not negative. And our asymptote, we moved down 7, so it's going to be y equals -7. And we'll do one more, y equals 4 to the -x. So first of all, find your parent function, write down your shifts or transformations, and your asymptote. Pause the video and do that now. So your parent function should be y equals 4 to the +x, so not too much different. And this one, since x is being negated, it tells us we're reflecting in the y-axis. Anytime you negate x, you reflect in the y. And our asymptote, since we don't have any vertical shifts, we're not moving it up or down at all, it would just be y equals 0. Okay, and last thing we're going to look at is some regression. So this is mostly done in your calculator. So what number are we on here? It's number 8. So for number 8, we've got this table I'm going to give you. Shows the number of new stores for a coffee shop that opened between 1986 through 1994. And with this data, I want you to use t equals 1 to represent 1986. Really important you follow those directions when that's given to you. And S of t for the number of new stores. And I want you to write the exponential regression equation for the data. And round all your values to the nearest 10,000th. And here's your table. So for the year, that'll be our X, and the number of new stores would be our Y. So we've got 1986, there are 14, 1987, 27, 1988 is 48, 1989 is 80, 1990 is 110, 1991 is 153, 1992 is 261, 1993 is 403, and 1994 is 681. So again, you want to use t equals 1 is 1986, so this would be your 1, then 2, 3, they're just going up by ones. So that's what we want to use in our calculator. Really important to write out your steps for your calculator, just like you did in algebra for linear regression. So you're going to go to Stat, then Edit, and then in for L1, we're going to type in our 1 through 9. And in for L2, we're going to type in the number of stores. So pause your video to do that. Stat, Edit, I already typed mine in. And now I'm going to go to Stat, then over to Calc, and choose Exp Reg, exponential regression, which is down here at 0. So my X list is going to be my L1. If you have something else in there, or you used a different list to store your X values, then you would just do second 1 or second 2. All the L1, L2, L3, L4, L5, or L6 are right on these 1 through 6 right here. We don't have a frequency list, and I don't need to store it, so I'm just going to calculate it. And it should give me this answer over here. Remember, when you are in regression, if you want the correlation coefficient, you need to make sure you turn the diagnostic on. So let's just review how to do that. So second 0, and then go down to the D's and scroll down to diagnostic on. Oh, I was there. And then hit enter, enter again. So then this time when I do it, notice now I see your R squared and your R. So your R is your correlation coefficient. If they are asking for that, that's something you'll want to have. So here we're also going to include Stat, Calc, Exp Reg, number 0. So what you'll also write out is, let's write out our equation that we see at the top of the screen. Write out your entire decimal for A and your entire decimal for B. And then show your substitutions into the equation. So put this in for A and put this one in for B. So our final equation would be, and actually we don't want to use Y because they said to use S of T and T. And it's really important that you use the letters they say, because you will get points taken off if you don't use those. So S of T would be, now we want to do 10 to the nearest 10,000th. So 10th, 100th, 1000th, 10,000. So now we look here. Oh, and there's a 9 next to it, so a little tricky. So we're going to have to bump this 5 up. So 5, 9, 6, 0. And then 10th, 100th, 1000th, 10,000th. So this one would be 1.5863 raised to the T would be our final answer there. All right, and then there's a second part to this question. Using this equation, so when it says that, it means you can use those rounded values. You don't have to use the really long decimals. So using this equation, determine how many stores the chain opened in 1996, round to the nearest integer. All right, so 1996, we need to figure out what that is in T, because we didn't use 1991, 1992. So if T equals 1 is 1986, figure out what t equals 1 is 1986, and we want 1996. You could also look here and say, okay, 1994 is 9, and we want to get to 1996, so that's 1995 would be 10, and 1996 then would be 11. So that would be t equals 11. So now we're just going to substitute into our equation to find what the number of stores is at S of 11. So everywhere I see a t, I'm going to replace it with an 11. And then pause the video, type that right into your calculator, write out the full decimal. And then we want to round, since this is number of stores, we'll round to the nearest store, so 1,696 stores. So something they could ask you too, like, is this realistic? You know, what if you chose another year? What do you think it would continue to rise? And, you know, maybe you'd say not really realistic because it's probably not going to follow this model forever. Because eventually you're going to have too many stores, and you'd have, you know, stores right next to each other if you're having that many stores with the exponential growth. So this would just be for a specific time period for that store. All right, and that is it for today. I hope you guys have a great day. Let me know if you have any questions. Pie out.